Hello, I'm Mark, and welcome back to part 2 of my video series on how to make a data-driven and dynamic spawn controller for your Unreal Engine games. So first off, let's do a quick little recap of what we did in part 1. So part 1 was all things data structures. And there were a lot of data structures that we built. Unfortunately, when dealing with a data-driven system, you're going to need to build a lot of data structures. So let's just do a quick little recap. So first off, we created a data structure for our static scene components. Then we created another data structure for our AIs. We created an AI group structure, so we could group our AIs into AI groups for organization. And then we created a data structure which will act as our table row so that we can put all of this into a nice data table. And then after that, we then created our save system data structures so that we could then save this information into a save object. So, and again, we had the one for the static actors, and then we created another one for our AIs. And then lastly, this is the actual object which gets put into the save system with all of our data so it can be serialized to the file system. All right, so that is a quick recap. So one thing I just wanted to add that I forgot to do in the last video was on the spawned pawns. So this is our AIs. I wanted to add another variable to the table, and this is, I'm just going to go ahead and just copy it over. And this is the B wants to reach origin, and this becomes important a little bit later on when we decide how we want to map our AI to a nav mesh. So by default, I'm going to set this to false, but what this is going to do is it's going to allow us to say if when spawning into a nav mesh, we have two options. We can either just spawn to a navigable surface, and that's pretty easy. The other option would be to spawn into a navigable surface that also has the ability to reach the origin point of where we're spawning in. And that can be useful if you wanted AIs which needed to be on a specific surface and you don't want them to kind of be disassociated when bringing into the nav mesh. And we'll go into more detail with that when we actually get to that piece of the code. But this is going to be a little setting that we can also add into the blueprint so that we can decide which one of these we want to use. So I'm just going to save that. I'm also going to go ahead and compile it, make sure that everything there is still good to go. Let it compile. Good compile. All right. So now with that out of the way, let's go ahead and set up our spawn controller. So I'm going to be doing the spawn controller as an actor component, and our spawn controller also needs to be able to work with nav mesh. So to do that, since we're going to be referencing the navigation system, we need to make sure that we add the navigation system to our build dependencies. So to do that, we're going to go to this file over here called mine's called dynamicspawnlive.build.cs, and as you can see, it already has some dependencies that were already generated for us, and these are all the dependencies that are needed just to get the default solution going. And we're going to just go ahead and add one more dependency. So I'm just going to add this as a second line, and that is the navigation system dependency. And so if you're ever wanting to know where to find these names, really all you need to do is you just need to go up to Unreal Engine, go into source code under Unreal Engine, and go to runtime. And then in runtime, the name that you want to put here is actually the name of the folder for the runtime dependencies here. So as you can see, we're going to be using navigation, which is down here. So that navigation system maps to that navigation system here. And if you're ever interested in knowing how Unreal Engine builds its navigation system, there it is in all of its source code. But we're not going to dive into that. We're just going to go ahead, and all we want here is the dependency. So we just grab the dependency. We'll just minimize all that in the source tree. And now that we have that, I'm just going to make sure we save it. And I'm just going to go ahead and just close this out. I'm also going to go ahead and just close these structures since we're not going to be using these. Well, we'll be using them, but we don't need to see them So I'm just going to close that up. I'll keep this one out because we still want to use this flag. All right, so saved. So let's go ahead and get that actor component created. So to do that, I'm going to go to the content drawer. I'm going to go to C++ class under here, and I'm going to right click, go to new C++ class, and I'm going to come down to actor component here. This is the one I want. Going to hit next. Going to make sure that I've got the public set up in the folder structure. And then let's go ahead and give this component a name. And I'm going to call it Dynamic Spawn Component. And I'm just going to go ahead and let's say create class. And we'll let Unreal Engine go ahead and just generate that class for us. Okay, it's taking a little bit of time. All right, now it's going to compile. Let's wait for the compiler. All right, good compile. Now let's go ahead and bring this up. I'm just going to say reload all, so it just reloads it into the solution. And there's our component. There's all our structures. There's our component. And so this is what Unreal Engine has created for us. This is just the boilerplate. And it's created this nice little boilerplate for us so that we can now go ahead and add the things that we need to add in here to turn this into a spawn controller component instead. So first off, I'm going to go ahead and add the references. So I'm going to put in, so this is a reference to our table row, and this is going to be a reference to our saved data structure. So those two references are there, so we will be needing them. And that is the only references we need to add into the header file. So next up, let's go ahead and start to flush this out. So first up, because I have that nice little mode setting, I'm managing that through an enum. So what we have is, so here we're just going to add the enum tag, enum, and all enums in Unreal Engine C++ start with an E prefix, and I'm just going to call it spawn in mode, and here's proximity, and here is the external, and then this is just the display metadata so that when it does show up in the blueprint it looks nice and neat. Alright, so that's the first. Next, I'm going to add a couple of delegates or dispatchers. Take your pick. So here's our delegate. So we're going to be adding dynamic multicast delegates, and the first one's going to be on spawn call, and then the other one's going to be on despawn call signature. So these are the signatures. There's no parameters in this, so these are 0 parameter delegates. We'll just call them, and they'll just, so anything that's listening in will know if it's spawned or if the spawner's been called or the despawner's called. And this is useful since this is going to be living in a host component or a host class. Then we might want to signal back up to the actor that this is living in to let it know that we've either spawned something or not, or despawned something. So next, we're going to go under public, and we're going to go ahead and I'm just going to go ahead and just add those two dispatchers or delegates, whichever you want to call them. So here they are. So again, there's a structure there, there's a structure there. That's how it's done. So on spawn and on despawn, and we've set the property to blueprint assignable. So again, these can be linked in through blueprints as well. Alrighty. So now that we've got that out of the way, let's go ahead and start to bring in all of the properties and protected functions that we're going to need to spawn in our scenarios. So the first one is going to be our enum. So again, this is our mode, and by default I'm just going to set it to proximity. But so whenever you're using an enum, as a switch, then you're going to want to use the T enum as byte. There's the enum reference, that's the type. And then here we're just going to set this by default to the proximity mode. Next, I'm going to go ahead and bring in our radiuses. So I'm going to set these to doubles. So spawn in radius and spawn out radius, they're set to doubles. So this is how we're going to then spawn in and spawn out. So this is closer, this is further away, and they're pretty large numbers right now. We'll dial them in a little bit when we start using instances of them in the blueprint. I'm going to add the debug flag so I can turn debugging on and off from the script. So that's there. I'm just going to hit the save button. And I'm also going to add in, so this is our reference to our data table. So it's a null pointer right now, so this allows us to pick the data table in the editor that we want this spawn controller to use. So you may have different types of scenario tables, and it allows you to kind of create like scenario packets. And so this one, and then each scenario system could use its own packet of scenarios. All right, so that's set there. And again, I'm using spawn controller. I'm using this pipe. That way, this is kind of on a sub level of this category. So the category is spawn controller, and then the subcategory here is tables. And the pipe will just give that, allow the editor to create that nice little subcategory look and feel within the editor. All right. Next is the arrays of transform points that we are going to be using for scene components and AIs. So the pawn spawn targets, this is where we want to spawn in all of our AI components. And then the scene spawns, this is where we're going to bring in that static scenery stuff. So these are the transforms that we will be taking from the host and putting into, and then we will then be pulling that information here. Next, I'm going to go ahead and I'm going to bring in just 2 of these. So the next 2 properties that I'm going to be bringing in, and again, as you can see, these are internal, they're protected, and they're not being exposed by the blueprints. So they're purely internal, so that they can be used by the component. Next is an actor. So this is my owning actor. So this is the host. And so on begin play, we will then set this to the host that this component is living in. And then we have the player controller reference, and this is what we're going to be using to help calculate the distance between the player and the spawn controller's host, so that we can, during proximity mode, we can know where the spawn in and spawn out radiuses are. I'm also going to add in at this level a do once flag. So we're going to be running the calculations within a loop. We want to have the ability to say only do this once until this flag's been set or reset. So that way we don't spawn in, spawn in, spawn in, spawn in. We create that nice spawn in and nice spawn out within that time loop. All right, so then we have begin play, and so I'm just going to leave that there. And so after that, we're going to go ahead and bring in our logic for our spawn in. So the first set of logic is going to be the get valid dynamic scenario row and get valid dynamic scenario by ID. And I'm just going to leave the green squigglies here. We'll fix that when we go ahead and put in the implementation. So first off, we'll just define what this header component is going to be first. Next, I'm going to put in the get a transform functions. So this will allow us to get those random transforms. So this is get the pawn spawn location, and then this is get the random transform. And so again, it just takes in the spawn pawn data, which is one of our data structures, and then this one's going to take in the origin, which will be the transform and the data structure, to allow us to go ahead and build that figure out what those actual transforms are going to be. And again, we'll get to that when we build out the implementation. Just going to bring those in twos. Next, we have the get random point in radius. So this is where we'll actually, when we pass in a origin point, this is where we'll decide, can we get this, can this AI spawn in on a nav mesh, and where on the nav mesh is it actually going to spawn in on. And then under here we have spawn new pawns. So this is the actual spawn code. And I also have the actor code as well. So, and I'm making these virtual just in case later on, as I'm kind of developing, I can then just inherit from this component and then just override these functions as needed if I want to tweak what's going on in here. But for now, we're just going to go with the base model. So that's new pawns, that's new scene actors. And the next two, I'm just going to bring in. All right, so then we have all scenarios pawns. So again, because we have the concept of groups, so here we'll pass in the group and the group index. And then here we have all scenario actors. So this will then help, this takes in an array of all of the those static classes that we want to create. Do that, and helps to generate that. So again, I like to keep things small. I like to keep things very, very function orientated in how I write, how I like to write my code. All right, the next two functions I'm just going to bring over. So virtual bool, create new scenario from row. So once we've got a row here, we're going to hand that row to this create function, which will then execute both this and this to generate all of the pawns and scenario scene components for us. And then I like to put this little error message function in here. This just allows me to turn on the screen function, error messaging or output messaging in the screen from the script. So, and just do it in a nice, clean, reusable function. And all it's doing is it's just taking in a string and a color for that string. And then finally, the last two functions that are going to be in the protected section are spawn new scenario and then spawn new scenario by ID. So this is the one that's going to be used by the proximity system, and this is the one which is going to be used if we want to spawn a specific scenario from an external source. So we have those two here. They're both internal. And that's that. Okay, so next we're going to go to the public. So as you can see, we have the tick component here. And we don't need to do anything with that right now. But this will be handling the ticks and how quickly we're going to be refreshing or checking for a scenario and stuff like that. So that's our time component. All right, so first two functions I'm going to bring over on the public side is the load spawn data. So these are the two functions that will allow us to load in and pull out data for our save and loading system. So again, and here we are with our saving and our save system data structure. So we'll take that structure, pass that in, we'll pass out the information, and then reconstitute the scenario on load. And then on save, we'll just take all the data that's valid and parse that into this structure and pass that back, where it'll then get saved into the saving system. All right. Next two functions. All right, so here we have two functions, the set custom pawn spawn points and the set custom actor spawn points. So the way we're going to set this up and the way to widgetize those transforms, those minor spawn points, right? Those are all done on the host. So on begin play, we want to take that information and pass that into our component here, and that's done through these two setters. And I'm just going to say I'm just doing a force in line. since it's pretty simple, just take the value and then just park it in there. Value, park it in there. So that's the pawn list, and that's the scene spawn targets list for the actors. All right, gonna hit save. All right, next. And the next public one is going to be our despawn current scenario. So this is the function that will get executed when we want to, if we have an active scenario that we want to remove. So there it is. This is the external spawn new scenario. So because these two functions are internal, and I want to keep them internal because I have that switch, we have this external spawn new scenario as well, and this will work in conjunction with that enumeration switch that we have, and it takes in an ID, but when we get to the logic, you can see if you don't pass in an ID, then we'll get a random. Otherwise, if you do pass in an ID, then we'll get an ID, as long as the spawn controller has been set to that external. All right, and then the last one, it may seem redundant, but when working with a save and loading system, it's actually pretty useful. It's begin spawner. And this is the one which we're going to want to call before, to actually activate the spawner. Otherwise, if we don't do this, then, or especially when we're running internal proximity, we could end up with two scenarios. One which would be the scenario that it picks, and then the other one would be the one which gets loaded in. And that would look kind of funky. So that's how we're going to manage that control loop. All right, so now that we've got we've now got the component defined, let's go ahead and move to implementation. So first up, we'll work on the implementation. We'll just go from top to bottom. So let's go ahead and fix that. Actually, first off, before we do that, we're actually going to go up and we're going to start with the constructor. I want to start with the constructor. So, and while I'm up in the constructor, I'm actually just going to go ahead and bring in all of the includes that I need. And just that way they're all there. So I'm going to be using the scenario row. Probably don't necessarily need that since it's already been defined in the header, but then I'm going to be using gameplay statics. I don't think I'm going to be using this, but I do have reference to it. But this is the math library, and then because we are using navigation for navmesh, we need to bring in the navigation system, and then this is so we can draw those debug spheres. So that's what those are for. So let's get started. So first off, the constructor. And the only thing I'm going to add into the constructor is set component tick enable. I'm going to set that to false. By setting this to false, this ensures that we're not going to start this component and start the tick component down here until we're actually ready to start the tick component. So it's set to false for now, and then we'll choose when to actually set the tick component to start ticking. And then while we're here, I'm just going to bring in begin play. And for begin play, the only thing we're going to do here is we're just going to say get the owner. So the component's going to get the owner and put it in the my owning actor variable. And then from there, just do this real quick. We're going to do a check to see is debug on and are we in proximity mode. If this is on and in proximity, then we'll go ahead and draw the spawn in radius and spawn out radius spheres so we can see where they are. Good for kind of debugging scenarios if you're using proximity. Alright, so now that we've got those defined, let's go ahead and start with all of these other functions. So first off is get valid dynamic scenario. So we'll just go ahead and click that. Right now it's just returning a null pointer. So for this one, I'm just going to go ahead and just grab all the code from the other solution. Bring it in. So here again, so what we're going to do is we're just going to go ahead and just create this empty row, set it to a null pointer. Next, most importantly, we want to check to make sure that that table has been set in the blueprint. If that table has not been set, then we don't want to execute this, otherwise the game will crash if it is null. And then once that's set, we're then going to say create an array, or we're going to create an array of type this row pointer, because we're going to be getting a list of pointers back, and that's all rows. And then we're going to be running this on this table. We're going to be running the get all rows function. So just take a look at what that's going to look like. You've got a lot of functions here on the table object. So we're going to be running get all rows, and as you can see, it takes a context string as well as the array of the output rows. So that's that. So there's a context string, there's the array, and that is an array of pointers. So once we get that back, we're going to check to make sure that we actually got rows back. So if we didn't get any rows back, this will be 0. So as long as we get rows back, now we're going to go ahead and say let's pick a random row, and because each row in our table is a different scenario that we might want to spawn in. So here it's a range between 0 and the number -1, because arrays are 0 based, where numbers are whole based. So this may say 1, but it's starting at 0. So to make sure that we get that correct, that's what we're going to do here. And we're just going to be using the fmath, and there's a static function on there called ranrange. Minimum is 0, max number -1. So if it's the first record, right, it'll be 0, 0, this will be 0. And if this is 0, then it will pull the first record. If we have 4 records in there and we want to pull the third record, this would come back as 3. 0, 1, 2, 3, yep. And that will pull back the 4th record, even though this says 4. All right, so, okay, so that's that. And so this will go ahead and get us a valid scenario, a random scenario from the table. Next, but we also might want to get a targeted scenario, and that's from the external. So I'm going to say potential fix. So to do that, we're going to do something a little different on that table. Let me just go grab that code real quick. All right, so here we have the spawn in scenario row, same idea, starts out the same table check, because we don't want to crash the game if there's no table there. And then instead of running get all rows, we're actually going to run find row. And so what this does, it does a very targeted search on the primary key index of that table. So find row. As you can see there, it takes the row name ID and again a context string. You can put nothing in there, or you can put something in there. It's really more for debugging, for logging purposes. And then we just set that to true. And we want to make sure that when it finds it, it returns it of this type. And if it returns it of this type, that means we've got the right table in there, and we'll get a row back. Otherwise, if we don't, it'll come back null, and we'll pass back a null. All right, so those are the, so that's those two functions. I'm just going to go scooch this up a little bit. So we've got some real estate. All right, next we're going to be working on, this is how we're going to go ahead and get our transform. So this function, and this function. So we'll start with get pawn spawn location, and I'm just going to say go different. Nope, I'm going to say go fix. My mistake. Yeah, show potential fixes. There we are. Green squigglies. And I'm just going to bring this in. So, and let's just do this to get the colors back. All right, so this is our get spawn location. And it's taking in the spawned pawns data structure. So first off, we're just going to create a transform, and I'm just going to call it composed. So what we're going to do is we're going to first make sure that, since this is highly configurable and we've, on the table, we're going to check to make sure that first off, this is turned on. So this is our Boolean switch. If this is not turned on, then we're automatically going to go to the else statement. If this is turned on, then we can then come to here and we'll check to make sure that we actually have targets in there. And we should. Oh, actually, we actually have targets that were defined by the host and that we brought those in. Then, if that's true, then we'll also check to see if the number of targets is greater than the transform point IDs. So since this is 0 based and this is number based, this should always be good. And then if this is all true, then it means that we want to spawn in on a transform point. So to do that, there's a couple of ways we could do that. So if you're kind of coming from blueprints into C++, you can do this through the Kismet library. So if you've worked with getting relative coordinates and turning them into real-world coordinates, you'd be using the composed transforms under the Kismet library. But all that does is it just goes ahead and just multiplies two transforms together. So we're just going to do that right here. So what we need, so our transform point here in this target is actually a relative location, right? And so if we just spawned in on this target, it would be relative to the middle of the map. But we don't want it to be relative to the middle of the map. We want it to actually be relative to the actual owning actor. So to do that, to make sure that we get, instead of getting the relative location, we want to get the world space location. What we do is we just take the owning actor transform here and multiply that by the relative location transform point that we want to use, and then that gets us the world space of that transform. Okay, so once we have that, so if we're good, we're using this. If we're not using this, then we're just going to go ahead and map it straight to the, we're just going to be using the actor transform location. So that's our first decision. Then we have the random location decision. And so we'll get to this function next, but in the flow, we're going to say if we're using random location, then we'll go ahead and use this function. If we're not using random location, right, we want it to be exactly either on the on here or on here, right? Then we're going to come down and then check to see, do we want a random rotation? So to do random rotation, we need a rotator. We're going to then say get a random range in that rotator on the yaw axis. And so if I just do this real quick, you can see, so the first one is pitch. We don't want to touch pitch. Yaw, that's on, I guess, the y-axis, right? And then, and we don't want to touch roll. So we only want yaw. So we want to randomly rotate the yaw between 0 and 360. That will give us a random rotation. So we put the random rot in there. And then again, you've got two options. If you're new and you want to use the Kismet library, then you've got the convert rotator to quaternarian, because the set rotation on the compose transform has to be done using quaternary, these things. I'm just going to comment that out. Or the other option is, since you have a rotator, this rotator object actually has a way of converting 360 degrees into this format, which is required by the set rotation. All right, so that will then, so that goes ahead and gets our pawns spawn location and rotation. So the next one is going to be, we're going to go ahead and get random transform. So to get random transform, I'm just going to come down here. Let's go ahead and fix this, bringing all that in. And I'm just going to go ahead and bring that in. So here we are for the random transform. Let's color code it. So get random transform, it's taking in an origin, and we're just bringing in the pawn data again. This is coming from the data set, from the data record. So here we're just going to create a spawn location, and then we're going to create this output variable here. So what we're going to do is we're actually got another function called get random point in radius, and it's going to return a true and a false, but it's also going to return an output variable, which is our location, right? Which is what we want to set the location and any rotation. And then what we have is this B wants to reach origin. So we're getting very close to how this is going to work. Okay, so once we get this, if we get a location back, if it's good, we'll go ahead and use this location, and we'll say take this transform and set its location to this location. Otherwise, if not, if it's a bad, we'll just go ahead and set it to the origin. And so that's that. And then again, we'll do if the random rotation is set, it's the same function as we used up here. We'll go ahead and run the rotation. We'll set it to the spawn, set the rotation, and then we're going to return the rotation, the transform with the location and rotation where we want to put in our, where we want to spawn in that that pawn actor or that pawn class. All right, so that's that. So let's get random transform. So the next function is this one. So let's go ahead and get this one done. All right, so this function is actually going to be using, in conjunction with the nav mesh. So let's just color code this. All right, so here we have the navigation system v1, and we're going to call it navsys, and we're going to just run this function called get current navigation system v1, give it the context, and this will bring back the navigation system class that the engine is using. We want to check to make sure it's still valid, because if this is not valid, we don't want to do any of this work down here. If it's, and we'll return false. Otherwise, if it is valid and we're good, then what we're going to do is we're going to create a random location, and I'm going to create a success flag, and I'm going to set this to false. Now, this is where we get this wants to reach origin, and I think we're ready for that discussion because, as you can see, I'll just scroll this up to try and maximize use. We have two functions. We have get random reachable point in radius, and then we have get random point in navigable radius. Okay, and they both do kind of the same thing, just one has a little bit of extra logic than the other. And to kind of understand that, I'm just going to bring the solution over, and I'm going to just, since I'm using a nav mesh, I'm just going to hit P to show the nav mesh being drawn out. So as you can see, anything in green is a navigable area. So if I choose a spawn point, say here, right, and I just want to use the navigable radius, but it doesn't, then it will take all of this green into consideration around that origin point, okay? And so it will spawn it up here on this block. It can spawn it on this block, right? As well as on the ground to that point. But if I set the flag to say wants to reach origin, which will then run the get random reachable point, right? Then what it's going to do is it's going to do an extra calculation. So if it finds a point up here, it's going to check to see if this can reach that. And as you can see, it can't. So if it can't reach it, then it needs to go find another point on the nav mesh that can reach it. So a little, splitting hairs, but it can be very useful, especially if you need to have if you're spawning in an AI and you need it to be able to, move to a location, or say have it move back into the origin for some reason, right? So that's what we're doing, and so we've set that flag. Probably 99% of scenarios, you're probably just going to say just pick a navigable surface and spawn it in, and we don't need to worry about it. But sometimes that there may be that 1% where you actually do, and so you have the option to turn that on. So well, that's what that's going to do. So we're just going to move this over here, move that back off screen. All right, so you have an option, and either one's going to bring back a location if it finds a location, right? If it doesn't find a location or a point that's suitable, it will return false. And if it returns false, then then this guy up here will just say, okay, use the origin. Otherwise, if it does find a point on the nav mesh where it can spawn in, then it will return that, and it will return true. So that's how that's all going to handle in there. All right, new parameters. So this is our spawning. So I'm just going to go ahead and bring both. So I'm actually going to be using two different ways to spawn in. And so there's a simple way to do it, and there's a more advanced way. I'm going to be for the AIs, which are in the spawn new pawns. We're going to be using spawn list. Why is that red squiggly? Oh, I know why. I forgot to add something up here. I'm just gonna put this down here. I forgot to add this. There's a lot of information in this component. So what we want to do is we actually want to manage the pawns and the actors that we're creating. So the component needs to know everything that it's creating. That way, when it needs to unspawn it, it knows what's in play. So I forgot to add that. And all we're doing is just using a tmap. This is the map class, and for a key, we're using the pawn pointer. And then we have the data as the actual object in there. So this is unique. This will always be unique because each character or each scene component we bring in is always going to be unique. So we can do that. Sorry about that. So that should satisfy that. Okay, good. So back to spawning. So there's two ways you can spawn spawn actors into Unreal Engine. One is through a regular spawn, the other one is through this deferred spawn. And a deferred spawn is used if you need to do some setup before you actually want to spawn the character in. So with a deferred spawn, what we're going to do is we're going to go ahead and create our pawn class here, right? And that's going to be taking in data from here, and this is the blueprint or class that we've selected in the table. So we'll select the blueprint of the pawn or the character that we want to bring in, and then this is the location that we went and determined from our get location functions, right? So we brought that in. So we'll go ahead, run the defer. So because these could be AIs, or most likely are going to be AIs. We want to set a couple of functions. So the first thing I'm going to do is auto possess AI, and I'm going to set that to place in world or spawned. So that means this will override whatever's in that blueprint to make sure that we have what we want. And we want this so that once this AI is spawned in, right, the controller will spawn in, and then if it's using a behavior tree, then that behavior tree will fire up and all of its AI processing can fire off. Then the second thing that we want to do is I want to add in this spawn in collision handling method. And I'm going to set this to adjust if possible, but don't spawn if colliding. So what we don't want to is two characters spawning right in on top of each other. If they do, that's going to look very weird and, potentially bad. So what this is going to do is it's going to say if you try and spawn this character in and something's already occupying that space, stop. Try and adjust it if possible. But if you can't adjust it, just abort the spawning. Okay, we're not going to spawn in. All right, and then I've just got if you want to add any additional logic, you can put it in here. And then we have this finish spawning here. And this will run the finalizer. And by running the finalizer, it will actually place it in the world stage, and it will also execute begin play and yada yada yada, everything else. So if you're using the deferred spawn and you suddenly see your characters just not show up, check to make sure that you're calling the finish spawning. So this will run the finalizer for you. And again, just make sure that it just requires just the spawn location again. So we'll just put that in there. So let's make sure we create that. And then what I'd like to do is I'm just going to check to make sure that we got a good pointer. So if this is all good and there's no issues, then we'll add this to our managing list right here. Okay, so the next one is going to be the new actors. And for that one, we're just going to do a simple spawn. So this is the other way of doing it. So this one, since this is, for me, it's just going to be usually static data. Then all I'm going to do is just say get world, spawn actor. This is the actor that I'm bringing in, actor class. Again, this is coming from our table. And then this is the location that we're going to be putting it into. And then if it's good, we'll add it to our managed list. And that's it. Again, I'm using this. If you've got additional things that you might want to set up before it spawns, you could elect to switch over and use the deferred spawn instead. Alright, so that's the actual spawn in process. So next up is going to be spawn all scenario pawns. So this is going to be, so this is a function that will take in a group and spawn all of those AIs into that group for us. So let's go ahead and do this. I'm just going to go ahead and just copy this over. I'm going to hit save. Let's just go ahead and just minimize this and minimize that. Alright, so, and let's just color coordinate that. So this is the spawn all scenario pawns in. So again, it's going to take the group and the group index. And then what I'm going to do here is we're just going to iterate through each group. And from here, this is where we're going to do our checks. So if the group size, if we're going to be using a min-max, right, then we're set for range. We'll then check the range. And then this is where, and then for each one in the group. So first off, we will get an index of how many we want to create. So that's what we'll do first. So if we're creating between 2 and 4 and we only set in it picks 2, we're only going to run this loop twice. If it picks 3, we'll run it 3 times. If it picks 4, it'll run it 4 times. And then max size is however many. Min size is always going to be the minimum amount of loops. Max will be the maximum amount of loops. Alright, so from there, again, get spawn location. So this will get us the transform. So here we pass in our information, our data structure. Here we'll get the spawn location back. Then we pass this into our other new function that we created up here, which is spawn new pawns, which is the spawn code. And there we're passing again that. We're also passing in the location that we just got and the index that we're not really doing much with in this example. All right, but then if the group size is just 1 for 1, then we're bringing in a single. Then we don't need to worry about the for logic. Then so all I do is we just say, okay, new parameters, spawn and group. And we just don't need to worry about running these extra loops here. All right, so that's in for spawn all scenario pawns. Next is we want to do the same thing for our scene actors. Okay, scene actors, again, let's just color code this. There's our actor, there's our spawn scene actor, there's our list. So we're bringing in the list, we're iterating through the list. We're going to do our check to see if we're spawning it into a transform. If we are, again, we want to make sure we compose to the real world location and not the relative. And then once we get the real world location of that transform, then we'll pass that information in with the actor data, right? And it will then go ahead and spawn it. Otherwise, if we're not using a relative location around off one of the transforms, then we're just going to go ahead and use this spawn actor. Well, first off, we'll make sure that we haven't added any actors into the solution, and then we'll go ahead and map it straight to on top of the actor. So this is just a little check to make sure we don't accidentally map 3 or 4 scene location pieces one on top of the other. So that's that. Yeah, and we're doing this because we're using a simple spawn. If we were using a deferred spawn, we could probably add the collision parameter check. But since we're just using a simple, we're just going to try and calculate that there. Alright, I'm just going to minimize this and this. Lots and lots of code. Alright, create scenario from rows. So once we get the row, we're going to pass the row into this. So this is going to go and take that row and create our scene component or scenario. So we're taking in a row pointer, so because we're taking in a pointer, let's validate the pointer. If the pointer is valid, right, then we will call, first off, I'm just going to go ahead and spawn in all of the static components, static scene components, let them come in first, and then once they've come in, then I'm going to set this group index, and then all I'm going to do is I'm just going to go into the pawn groups, and then iterate through the groups, passing that information into spawn all scenario pawns, and then that will handle all of that. And then once this is all done, we'll do a broadcast on our delegate, and we'll set him back a true on that. And if this fails for any reason, we'll return false. Alrighty. Next up, I'm going to do the error message. This is a real easy one. Again, if debugging's turned on, what we'll do is we'll check to make sure that we have a valid engine, and then if the engine's valid, then we'll say we'll just add on the screen debug message. That's -1 for 5 seconds. There's the color, there's the message, and set that to true so it persists for a little bit. Alright, that's pretty simple there. And then the last 2 internal functions, we have spawn new scenario, and then we have spawn new scenario by ID. And I'm just going to go ahead and fix both of these at the same time, since they do roughly the same thing, just a little bit of variation. So this is one for new scenario, so this is getting a random scenario. So first off, what I want to do is I want to do a check to make sure that we don't have a scenario currently in play. And to do that, I'm just going to go against the spawned pawn list and the spawned actor list. As long as they're less than 1, i.e. 0, so that's what this is doing. If the number is greater than 0, we're going to return false, and we're going to return false. So if we have anything in these lists, then we have a scenario which is currently in play, which means that we need to unspawn before we run this to clear that all out. Otherwise, if these lists are clean, then we'll go ahead and get a valid scenario from the table, pass that back, and then we'll just go ahead and create the scenario from the row. And then it's something similar down here. The only difference here, it's same idea, check to make sure that nothing's actually in play. Only difference is we're going to say get valid dynamic scenario by ID, and we just pass the ID in. And then everything else down here is about the same. All right, so that should do it for all of our internal logic. So now let's move down to our public code. So first off, tick component. So I'm just going to go to definition of the tick component, and let's go ahead and set up our tick component. So if we are set to internal proximity, then we're going to manage that within the component. So again, proximity is set to true. Tick has been started, so this is now ticking. This is set to true, so it will automatically go in. We're going to check to see if we have a controller. If this is null, then we'll go ahead and get the controller, and we're going to do that through gameplay statics, get player controller. We're going to put the get world in for the context, and we want player 1, which is at position 0. And all I'm doing is I'm just bringing back a standard player controller to put into there. And then from there, we're just going to say get pawn. And this is the controlled pawn, right? And the reason why I'm going to say I want to get the controlled, I'm doing it this way, is because if you had a video game in which you had a character which could get on and off a mount, then technically you're going to be then possessing them. Your character's then going to put, your controller's going to possess the mount. And so your character gets on there, you weld them onto the mount, and then, but while the controller gets possessed into the mount, okay, so now it's the mount's location, not the character's location. And so this allows us to, this gives us more flexibility in making sure that we have the most current location of whatever is hosting this controller. So get pawn, and we're going to do this on every tick, just to make sure we've got the most relevant. That way, if we're moving between characters and vehicles and back again, we'll always have the most relevant location. Once we get that, we're going to do a distance check. So again, there's two ways you can do it. You can either do it through the Kismet library using the vector distance, where we're going to put in the... So this is the location of the host that is hosting this spawn controller. And this is the location of the control pawn. If you don't want to use Kismet, then on the F vector, there's a static function called distance. And you can then, it's the same thing, owning character location, control pawn location, and then that will get the distance for you off that. Disclosure, this just does this. So I'm just going to do that. All right, so once we have the distance, then we're going to do a distance check. And because we're doing this in a time loop, that's where we have to have the do once. So we're going to do a distance check to say, so if we are within the spawn in radius, and this is set to true, i.e. we can spawn, we're going to first set this flag to false, and then we'll spawn in the scenario. That way, when this comes back on the second tick, this is now set to false. Even if we're within radius, we're now going to execute this. So then we're going to come down here and we're going to do a distance check on spawn out, right? And so if this distance, if we are now on the outside of this spawn out radius, and this flag is set to false, we're now going to set it back to true, and we will run the despawn scenario function to clear out whatever's there. So that's everything that we need to run in the tick components. All done. Okie dokie. So next up, after tick, we have spawn load in data and load out. So these are the functions that we're going to be using so that our save system can that we can use to interact with our save system. So, or a save system. So I'm just going to fix both of those and just bring these in. So the first one is going to be our load. I'm just going to copy this. Put that there. So what we're doing, I've got a Boolean flag here to say if we actually loaded something or not, and the way we're going to check that is by checking this index. So what we're going to do is we've got load spawn data. So what happens is we'll go and pass in that saved data, right? And then from that saved data, let me just color code this. We're going to first, I'm going to start off with the actors and we'll spawn in the actors. We're just going to reuse the spawn code. The only difference here is that rather than taking off the table, we're just taking it straight from this saved data structure instead. So save data actor, and rather than, and this is the actual location that we want to bring it in. So that was the last location. So that's the when we saved it. So that's the location we're going to bring it in. And then we do the same thing for our pawn, our AIs, pawns and characters and AIs, right? Same idea. We iterate through, and then here again we're just going to run the spawner that will spawn it all in, and then we have our index here. And then what we do is we check to say, so if both these loops ran, then this index will be greater than 0, so we can return true, and this will let us know that we actually loaded in a scenario, so we shouldn't be wanting to spawn one in on top of it. Otherwise, if it returns false, it means we didn't load anything in, so our spawner should be then free to go do whatever it needs to do. And then the flip side is saving all that data. So I'm going to come here. I'm just going to bring this in. I'm just going to go ahead and minimize and minimize. So pretty big function, but this is just saving the data. So we're going to create a saved data structure called save data. First, we're going to check to make sure see if we have any actors, scene components that we want to bring in that we want to save. If we do, then again, because it's in a map, so we're using these maps, we have to access them a little differently than we would an array. So first off, we need to go get a list of the keys, and those keys are, the actual things that we spawned in. So we'll go ahead, get that list, put it into an array. So that's what this does. So get keys is on the map. So there's a lot of things in here, and we're just using the get keys, and as you can see, it's just going to return all the keys for us. And once we get the keys, then we're just going to iterate through that key list, right? And I'm just going to put it's not really an error message, but it's a debugging message, which is save spawn data, and I'm going to put that in black. And then first I'm going to make sure that this is a valid point. This is a valid pointer. So I don't want to save anything which is null. Bad idea. And again, this could cause things to the game to crash if we did try to do that. So first, make sure it's valid. Again, create this spawned actor data save class, and then we're going to put the spawn actor lists. So again, we're just going to put the key in. We're going to find. So there's two ways to do this. There's a find and then there's a find ref. If we just use the find, it's going to pull a pointer back, but we can't put a pointer into here, right? Because that's not going to serialize very well. So what we actually want is the actual value. So that's why we're going to use find ref instead, which will say it does the same thing find does, but then it does one extra step and says, no, don't bring back the pointer. Bring back, make a copy of it and bring back the actual value instead. And then spawn location, again, we're going to take get the actor, get the transform of that location, put it in there, and then we just add this data to the list of scene components that we want to save. And then it's the same thing for the pawn list. So we'll take a look, spawn pawns. If we have them, then let's go ahead and get a list of them. Make sure that each one of these is valid. It hasn't been destroyed externally or through other means. So if it's valid, again, we'll find the reference, get the transform, put that in there, hit save, bring it into the save object, and then we're going to return the saved packet back so it can be saved within our save game file. Alrighty, so that's the save and loading. Don't need to do anything here, we've forced inlined it. So then despawn current scenario. So this is public because there may be several reasons to despawn a scenario that's in play. So let's go ahead and just bring this in. And I'm just going to go copy and bring that in so we can discuss what I'm doing. And I will just minimize that. All right, so this is our despawn. So again, first thing I'm going to do is check to make sure that we have something that needs to be despawned. And we're going to start with the actors first. So again, very similar to what we did in the save data. The only difference is that we're just going to run this destroy. So same idea, get the keys, iterate through the keys, right? But first make sure that that key is valid and that this actor has not been destroyed by anything else. And if it is valid, then we can go ahead and destroy it. And then we'll, now if it's not valid, right, it's already null. We're just going to remove it anyway from the list. And then I just finally, once we've gone through the entire list, I just run an empty anyway, just to make sure that there's just no other dirty data in there that we're not taking into account. So that's what that does. And then it's just a secondary check. And then we do the same thing for all of our spawned in pawns, right? We're just going to go ahead and check to make sure we have something to do. If we do, get the keys from the list. We're going to run the destroy if it's valid, and then we'll remove it from the list. And then once everything's been removed, we'll just go ahead and just double check to make sure it's empty. And then after that, once all of this is done, we'll do a broadcast to say, hey, we've just been executed. And despawn has been executed. And then this will broadcast to anything that's listening. All right, so that's despawn the current scenario. All right, so 2 more, and then we should be done with this component. So I'm just going to go ahead and show potential fixes. So this is the external function that we can call, and I'm just going to go ahead and just copy it. All right, so if we're going to be running in external mode versus internal, then for our component, then we'll be using this function here, and we'll be providing it with an ID, which is the ID on the table that we want of the snare we want it to bring in. First, we'll select to make sure that we're in the external mode. Then we'll check to see if there's an ID provided. If there's no ID provided, we'll despawn, but then we'll just go get a random scenario. If an ID is provided, we'll despawn, and then we'll go get the scenario that that's been requested. And so that's all that's doing there. And we're just using the is none on the fname structure to determine whether there's something in there or not. All right, and then finally the last one. So this is a very simple function, but it's here because we have a saving and loading system. We need to make sure that we don't start, especially the internal proximity, too soon. So again, this just ensures order of operation. So begin spawn again, if we're set to proximity, that's when we'll set the enable trick to true. And so that's where we'll actually take this component and turn ticks on. And we want this here just in case in the host, it's going to load the data first before it does this. But if there's nothing to load, then it'll just go ahead and execute this anyway. But we want to make sure that we run, if we have a saving loading system, we want to make sure that this runs and loads in first successfully before we actually start anything. Otherwise, we could end up having two scenarios on top of each other when when the user reloads the game. All right, so that's a lot of code for our components. And let's just go ahead and make sure we've got a good compile. So I'm just going to go ahead and run this, make sure we have no errors. And whew, we have a good compile. All right, so that will do it for the components. So this is going to end. I'm going to stop it here. This is part 2. We've built the so in part 1 we built the data structures. In part 2 we have gone ahead and created the component that will use those data structures. And so in part 3 what we'll do is we will then switch to blueprints. So we'll put the compiler down and we'll do everything else in the editor. So we'll go ahead and create a host for this component. We'll go ahead and build some scenarios in part 3 out to test this out in all of its modes, and that will be it. So once again, if you like what I'm doing, feel free to like and share my videos, as well as subscribe to my channel, and I will see you again in part 3. Cheers.